Yeah. So basically, this normal distribution is something that is used for us to find out how is my data distributed across. So any natural phenomena follows this normal distribution. Like maybe you can take a sales of a company or an organization. Slowly, when you start the organization, the sales might be here, it will not be very much. And as you develop more and more, the sales goes up, and at some point of time, the company will be at its peak. And after that, what happens? Slowly, it starts to decline and it comes down, right? So where it started, it comes to that level. Not all organizations, I'm saying most of the organizations, this kind of peak will be there. So whenever we are going to represent this data, whenever we wanted to find out a pattern or try to do some advanced analytics on top of this data, we'll need to represent this particular information in a form of a normal distribution, right? So once you take a data and represent it in form of a normal distribution, what happens? Basically, you get an idea about where is this data, what is its lower value, what is its upper value, how is my distribution of this data there overall. So I get to see a lot of information across, right? So with this information, I'll be able to do lot many things. So hence, I'm making use of this normal distribution there. Oh, right. So hence, I'm basically finding out a normal distribution. So basically, you can also take it takes like it fits the probability distribution of various events. So this helps us to know like the probability distribution of various events that are happening, and it tries to represent it in form of a bell curve. So that's where this normal distribution is used, right? And we did create a normal distribution, and we were using something called distribution plot. So that is the one that we will be using. We were using it, and KDE basically meant it is for a normal distribution. Okay. So I hope the concept of normal distribution is clear for you all, right? So now, as we have seen about the normal distribution, and we also saw about the standard deviation, mean, median, mode. So when to use mean, when to use median, and when to use mode, maybe Raghav and Sashi together, you can take up one. So when do we use mean, Raghav?
Mean is the starting state of initial values.
No, no.
When we
My
have the
question is,
certain range of data, we use the mean, average, nothing but average.
okay. No, what is no? My question is, see, there are three measures of central tendency: mean, median, and mode. Okay.
Yes.
So, in what kind of data I'll be using mean? In what kind of data I'll be using mode?
Yeah,
And
certain
what kind of data?
there is
Yeah.
there is no much outliers within the
Hmm.
data set.
Yes.
The data range is lesser than 100 or something, yeah, near to 10, 20 between, for
Hmm.
example, as we discussed, it is between the less distance between first
Yes.
minimum and maximum value. Then we use the mean value. If we
Mm-hmm.
have the outages at the time,
Mm-hmm.
we use the median value, which is between two. If we have more outages above 100 to 100, which is not forming in the bell curve, it is supposed
Hmm.
to,
Hmm.
when we use the outages are more, when then time we use the median, it is adding middle two values.
Yeah.
It is taking as of middle two values. Mode is value come from mode is for that which
Maybe
is
Raghav can tell this. Raghav can
yeah.
tell this. Raghav, can you tell me why? When do we use mode?
Mode is we want find out the most common value or category data sets.
Yes, exactly. So categorical data sets, whenever we are having, when there is like some missing
For like
values.
a survey asking the report most frequency to questions like yes or no, that kind of most
Mm.
popular
So
answers.
in case there are missing values, we will generally consider mode and try to replace that missing values with mode, right? So that's where we'll make use of mode. Okay, so these concepts are very, very important. So that's why I am reiterating and asking you guys again. So today we'll see a concept called variance. Okay, so what is this variance? This is also very similar to that of standard deviation, variance. But also what this variance helps us is, it basically helps us to measure the spread or dispersion of the data. So what is dispersion? Dispersion is how spread the data is. So it basically tells us something very similar to that of within a bell curve, assume like there are few points here, few points here, some are here. So it basically says how far away the data is from the mean. So when you are computing a variance, what happens is, if a variance is computed, so it basically helps us to say like how far away the data is from the mean. So low variance means the data is highly concentrated, we can say. High variance means the data is highly spread, we can tell. Okay, but let's understand how this variance basically works. So there is a formula for variance. So let me open Google and show you the formula. I will not be able to. Okay, so the formula for variance is this, right? So as I told you, this basically indicates a spread of this data. So you see, this is how a variance is calculated. I hope you are able to see the screen, right? So they have put the value x minus x bar the whole squared. What is this? This is basically mean value, and they are taking each and every value, and I equal to 1 to n means if there are 10 records from I equal to 1 from 10, it takes each and every value and they try to assign this value here, and they find the difference between that particular value and the mean, and they square this particular value. So standard deviation and mean is basically square root of, if you square the standard deviation, that becomes mean. Sorry, that becomes variance. Sorry, that becomes a variance. So standard deviation and variance are closely related. But in terms of formula, if you see in standard deviation, we take a square root. If you remember the formula yesterday, what we were saying. In standard deviation, we take a square root, but here we just do a square alone, that is square to the power of 2. So that's the basic difference, but these can be used interchangeably. Okay, but this is also one of the important metrics in order to find the dispersion of our data. So hence we are seeing about the mean variance as well. Okay. So you got some fair idea about what variance is, everyone?
Yes, sir.
And Deepa, maybe for you, variance is something that you should understand first, standard deviation. So
Yeah,
then only I
no
think
worries.
you'll be able to get this. But maybe yeah, we can see this in detail during our.
Okay.
Right. So now we'll compute the variance. So how are you going to compute? How did we compute the standard deviation, guys? Raghav, Sashi? How did we compute the standard deviation yesterday? We were working on with some examples, right?
Yes, sir.
So how did we find? So from NumPy, we did say
Yes.
NP dot standard deviation. So for the same data, let's make use of the same data what we were using for yesterday's example. So here we found the standard deviation. The same way, let's make use of the same data. I'm going to use a very similar records what we were using yesterday. So this is what the data will be having. It will be having all the values as here, right? So now let's insert a new cell here after this standard deviation. Okay, so I'm going to make use of the same data. So I'm going to say variance data. Okay, so here what I'm going to say is there is in NumPy, there is a function called variances already there. So how it is represented, it like std. So there is something called variance also. So I'm going to print you both. Okay, print. So what we'll also do is np dot standard deviation of data. Let's print both. Okay, so I'll display the standard deviation and variance together. Okay, you see the difference. You see 8.7 was your standard deviation. If you just roundly square this, so 8.7 into 8.7 is how much? So roughly it should be coming closer to 70, I think. 8.7 into 8.7. See, which comes to 75.69, which will be our 75.70. This is displayed the record, right, with the decimal places. So basically what will happen is this variance will be squared of the standard deviation. Okay, but what is something to understand about this variances basically is this also helps us to gauge the spread of the data from the mean. If there is a high variance means the data is spread across. What we can understand is when the variance is very low or when it is closer, that means it is not spread that much, right? So this basically, as data scientists, how this helps us is it basically helps us to say like how much data is varying within the data set. So because this is crucial for understanding the patterns within the data, identifying unusual data points, the outliers, what you guys were talking about. This particular metric is very much important to know about the outlier detections and these things and all. How is your data there? So without understanding what is going to be in your data, you will not be able to create any models, right? So there is no point in just knowing these terms alone, because you need to understand how is this data spread across. So without knowing how the data is spread across, we will not be able to come to any conclusion with the data. Right? So that's why we'll be understanding and knowing about these concepts more. Right? So I hope this variance is clear for you all. Any questions, Raghav, Sashi, or Deepa? Sorry, Raghav, your voice is very low.
Which is mean value, sir?
Mean value?
Mean value 8.7 something. It's the
No. Here I didn't put the mean. The mean value is not this. So how would you compute the mean? This is not mean. This is standard deviation. How will you find the mean? Is there a function called mean?
np.mean.
Yeah. Yes. So mean value I have not computed, right? Where did you find the mean value here, Raghav?
using mean.
I didn't compute the mean itself. The mean is 171. Why the mean is 171? Because it is, I think there are no outliers here. So 171 is the mean. So basically this variance, standard deviation is saying all values are not that spread across. So the deviation from the mean is like only 8 or something. The variance is basically saying like though the data is there, it is like the variability of the data is somewhat there. So for example, it is ranging from I think 160 until 185 or 90 it is going on. So that's why it is giving us a specific number for variance. So its maximum is 190, minimum is 160. right? Around 30 it is moving. So it will not be exact difference here, but it will be a measure to tell like, okay, if this number is too huge, then we can basically understand the data is spread across and it is quite scattered, the data. That's what this will help us to understand. Okay, so everything revolves around the mean only. So mean is a very important metric, but these are the things which will come on top of the mean. Okay, so if you guys are okay with these concepts, let's move on to something called binomial distribution. Have you guys heard the term binomial distribution?
Yeah, sir.
Where did you study binomial distribution?
10th standard.
Yeah, so and okay, Sashi or Deepa, you have some idea on what this binomial distribution is?
No, I don't even recall.
Okay, great, no problem. Okay, see, binomial distribution is nothing but a probability distribution. Okay, it is same like our probability distribution only. What we were saying, Raghav and Sashi, you guys will be able to relate it more. So, but what happens is, this particular distribution will be able to help us model the number of successes. So basically, note this term. It is basically helping us to find out the number of successes in a fixed number of independent trials. Okay. So for example, I'm tossing a coin. Okay. Assume we are doing a toss. So I wanted to determine the number of successes alone from here. For example, if I'm calling for head, how many times head will come? If I'm calling for tail, how many times tail will come? Right. So here, this particular binomial distribution is basically going to help me to find out the number of successes or the number of failures. So either if I'm tossing a coin, either I'll be getting heads or I'll be getting tails. So this is basically going to help me understand whether I'm going to get heads or tails, or if at all I'm going to get heads, what will be that percentage or probability, or if I'm going to get tails, what will be that probability, right? So when you are going to toss a particular coin, each time you are going to toss a coin, assume it is a fair coin, which means it is flattened coin and each side has equal probability to get that, right? So in that case, each trial has an independent chance for success. So basically what we are saying is each trial will be having been computed independently. So there is a formula for this binomial distribution. It's a quite complex formula, but you don't have to remember any of these formulas here, right? So the formula for binomial distribution will be something like this. You see, they are trying to find out what is the success. You see the probability values they have mentioned here, p equal to 0.5, 0.7. N is the number of trials, p is the probability. So probability is 0.5 and the number of trials is 20, and so they are representing blue, green and red. So I'm assuming each one are different events, and they are trying to say like for each of these events, what is the probability. So here basically what they do is, this is the formula for this. Um, First, we are supposed to find out the probability mass function or something, but don't worry about these formulas. So it's quite complex formula, right? So basically here they are trying to compute for a biased coin, what is going to be the number of probabilities that we are going to get heads, exactly 4 heads in 6 tosses. You see? So if I'm going to put tossing a coin for 6 times, what is the probability that I'm going to get exactly 4 heads out of 6 trials? right? So that is where the probability is. And you see, when you are applying into this formula, this is basically a positive outcome, which is they are computing as a probability of 0.3. So already they compute a probability for each of this, so which will be 0.3, and they'll be applying it in this formula. Not to worry much about the formula, but just understand this binomial distribution is basically going to deal with uncertainties and certainties. So there is a particular equation for this works. So everything is already fed into Python. So you don't have to remember any of these formulas or complex things. You just need to know how are you going to call this particular formula and how it will work. Okay. So in a binomial distribution, as we were saying, it has three parameters. One will be the number of trials. So as I told you, the number of trials is going to be number of times you are going to toss a coin. So 10 times you are going to toss a coin, then your n will be 10. Okay, and the second one that is required is probability occurrence of each trial. So what is the probability of tossing a coin?
50%.
Either head or tail?
50%.
Yes, 50% or 0.5. So
Yeah,
if we are
0.5.
going to represent it within 0 to 1, then we say the probability will be 0.5, right? And the third thing that is required is what is going to be the shape of this array, or what is going to be the numbers basically. So here basically we can say in an array, whenever we are representing, we define the size of the array, right? The same way we'll be just giving a particular size there. So basically it will be n equal to 10 or size equal to 5. Likewise, we will be representing this. Okay. So now let's see how are we going to implement this in Python. Okay. So as you know, each event of tossing a coin is an independent event, right? So so maybe I'm going to take 10 trials, 10 trials. So my n is going to be 10 here, and the size of this array I'm taking 10, 0 to 10, right? Or something within that range. I'm going to define that array.
Are you showing
Okay.
something, sir?
No, I have not started typing. So here also we are going to use NumPy only. So from NumPy, we are going to import a module called random. So you know about random. So this random is what it basically helps us to understand how many random values it can generate. So since we are going to work with arrays here and in NumPy, so there is something called within random, there is something called binomial. There is a function. Okay. There is a direct function called binomial. I'm going to make use of this. So I told you my number of trials are going to be 10 trials I wanted to try. The probability of each trial is 0.5 because I'm going to toss a coin. And the size here is going to be 10 data points. So I'm taking 10 as my size.
What is
Okay.
mean by size, sir?
So size is in array generally what we say as size, right? So
Yes.
if a size of an array 5 cross 5, so which will be 25, right? So similarly, when I'm saying size as 10, it is a unidimensional or a no dimensional array, which is just going to have 10 data points.
Okay.
Right.
Means
So that's
here,
what the size.
yeah, got it. It will work only for binary data only. True or
Which
false? This
no, not
formula.
only. So this probability can change. So assume like you are instead of tossing a coin, assume like you are trying to see like whether this guy is going to hit a 6 or 4 in this ball. So assume in a cricket, if one ball is going to be tossed or one ball is going to be bowled, so you want to find whether the probability of whether it is going to be hit or a miss, right?
But
So generally when
Ramesh,
cricket
okay.
matches and all they used to show, right?
Means the
What is the
outcome should
probability?
be only true
No,
or
not true
false.
alone. It can be false also, right? So if there is a lesser probability, you are going to say like 0.2 percentage only, there is 80% chance that it will fail, right? Like lottery and all, buying a lottery ticket and all will have very low probability because one in 100,000 people only will be getting that, right? So in that case, the lottery probability will be 1 divided by 100,000.
Yes.
So which will be 0.0000 something, right? So the probability can be anything here, but you should be defining that prayer probability here for this binomial, because here since we are taking an example of tossing a coin, we know the probability is 0.5. Hence we are mentioning it as 0.5 itself. Okay, you are getting this equation, everyone? Okay, if no questions, let me execute this and show it to you. See what this has done. Basically, it has computed my value of x here. So totally it has taken 10 trials, a sample size of 0 to 10, and it is saying for this particular distribution of tossing a coin, what is this number from 0 to 10? It is giving me the first trial has a chance of 6, second trial has only 4, the third is having 5, 3, and then likewise it is trying to distribute this. Okay. See, for each and every time this is there, this value will change. So mostly if it is a fair coin, see if I'm going to reduce this probability, then you see what happens. I'm just going to make it as 0.3 only. Now you see, this will be the output of this, but let me not execute it here. Let me execute it down and show it to you. Let me make the probability here as 0.5 only. Let me reduce the probability here as 0.3. You see now? So once I reduce my probability to 0.3, all the values of the size has come down below 5. You see, not even a single item, it is basically predicting it as or closer to 5, or any number of trials that you are going to give, maybe one or once or twice it is coming 5, but not much, right? So even when it is taking 6 and 8 in some cases, but it has reduced the size or the values for rest of all the cases, you can see, right? So based on the probability, this will basically say like in my probability, this particular tosses, if I'm going to put 10 times toss with a probability of 0.5, my chances of winning will be this, like 1, 2, 3, 3 times, 4 times out of 10. 10
Yeah, why
trials.
you mentioned the n equal to 10, size equal to 10? So both values are same or different, sir?
No, I can mention any size equal to 100 also, but it will be too many records. So in order to just show you only 5 records or 10 records, this is the number of this is number of trials, right? And this will be the size. So you know size, right? In NumPy, you have seen size. What the size is going to do, it is going to assign values between 0 to 5, right? So if I'm going to give 10 here, it is going to assign the values between 0 to 10.
But n equal to, sir?
N is what?
Number of times.
Sashi, what did I say for N?
Number of times we tossed.
Yes. So if you're going to toss a coin for 10 times with a probability of 0.5, and the size will be between 0 and 5, this is the numbers that we get.
The probability is 0.5. How to be is any mathematical?
You know, for a coin, so when I was talking to you about probability, Raghav, I told you for a coin, so any probability will be ranging from what value to what value?
50-50, sir.
50-50. So if I'm going to represent it within 0 and 1, then what will be my value for my probability?
50-50.
No,
0.5.
0 and 1. 0 and
0
1.
and 1.
So 0.5, right?
Yeah.
So why I'm giving it as 0.5? Because my outcome, so I showed you an example the other day. You remember tossing a dice versus tossing a coin. So why
Sir, we
tossing a
take the
coin?
example with cards, sir. It's very complicated but easy to understand.
Which cards? So,
Yeah.
but I'm not very sure how many cards we have because I'm not very familiar with
Totally
cards.
4 colors in 13 cards.
So 13 fours are how much then?
56.
52, right?
Yeah.
So then what will be your probability of getting a particular card?
Yeah, I think so.
Yeah, assume A R10. So what will be the probability of getting A R10?
It's a one time.
One time out of?
It's a ART, it's a one time, it's a moving 1%, sir.
No, that's true. My question is one out of how many cards?
52.
That means what will be your probability?
0.019.
Yes, right. So the same, so for
Only
you,
A
let's
is
take,
only one card only. How many
Yeah,
cards in
uh,
ART.
52?
yeah, he's taking only one card. So that will be AR10. See,
Totally
Okay.
A is a 4 color. Diamond, 18,
Okay, okay,
third,
okay, okay.
clever. So I
so
mentioned
But
only
he
1
is
for
divided
ART.
by 52,
32.
right?
No, sir.
Yeah.
52 4 divided by 52.
Why?
He's
He's
saying
taking only one card, right? Is he
One
taking
one
card
four
is
card,
a
cards?
ship.
one card, but we have 4 A's, sir, right? In
No,
52,
but ART is only one card.
only one card.
Yeah.
Yeah,
How you
yeah.
say?
That's why. So that's why we are taking
We
one.
need to learn
Okay.
cards.
Yes, yes, yeah. That's what even
Card is
I
the
I'm
always
not very
follow Indian school today.
even I'm not very familiar with cards,
Card
so I
is
didn't
not
take
to
that.
understand.
Yeah. So I took a very simple example. So as per your understanding, Sashi, Raghav, so let's take 0.019 and the size I'm mentioning as 52. So number of trials I'm going to take as, let's take only one trial. Okay, now let's see what it is going to give. So not even only once also there is no possibility it is showing because why it is showing that? See, the probability itself is 0.019. So which means 1 in thousands or maybe in that many iterations you might have to play in order to get this. So at least let's say 10 trials. Yeah, you see, in a 10 trial, there is a possibility of 1, 2, 3, 4, 5, 6, 7. Every 7 times, at least there is a possibility of getting one AR10. So as per
Sir,
you,
you see
Raghav.
the next series, it's a double on sum.
Yeah, yeah. No, see, this is a probability only, right? So it will not follow any specific pattern. Sometimes it can be double one. Now this double one has moved here, you
No
see.
guarantee.
No guarantee. Yes.
No
So do
guarantee.
you have a
Why,
guarantee
sir,
for
we got
buying a
it?
lottery? Do you have a guarantee for
He-
buying a lottery, Raghav?
No,
no.
sir, it's a mathematical operation. It's showing all accuracy. So that I am asking.
Mm. No, it is basically what it is saying is, see, out of the number of trials that you are going to do, 52 times you are going to do this trial. So there is a possibility that every 10 times once you might get, right? So it is not confirmly saying you will get, you might get, right? So that's how this game of this lottery and these things works, right? So 1 in 10 lakh people in one, they will be able to win that lottery. But the amount will be huge. But that's how the concept of lottery also works. Okay. Okay, now let's quickly see. We saw about normal distribution. We saw about binomial distribution. Let's now quickly compare and see both of these distributions so that we get some clarity in terms of what is what, right? So for the same data, what we'll be taking, I think let's put across both normal distribution and binomial distribution. Okay, so so before going on with the comparison between this, I'll visually show you this also, so that you have an idea on how this normal binomial distribution is coming. So I'm going to, from import, I have already imported random, so I'm not going to do this. I'm just going to say import matplotlib dot pyplot as plt, cbon as this. Okay, and now what I'm going to do is I'm basically going to show you a distribution plot for the same size, right? For the same thing, I'm just going to show you a distribution plot. So I'm not going to show it with kind equal to KDE. Maybe this is not required now, but I'll just reserve it for the later part. Okay, so I'm just going to say the size is 52, which is 52 cards, and this is 0.19. So it is basically going to tell me a distribution of how my particular, what happened, import matplotlib.pyplot as no module name matplotlib.
Import C.
Why?
Okay.
No, it is saying there is no module name matplotlib. Why?
H sir, H, remove H. Math.
Ah, right.
MAT.
Yeah, you see. Yeah, you are right. Matplotlib dot. Yeah, I was wondering what has happened. Why this is not coming. Okay, yeah, now it should work.
MATLAB,
Mat,
sir.
one minute.
Yeah.
Matplotlib, yeah. Still sorry, I missed one. Matplotlib dot pyplot. Okay, yeah, this should come now. You see? Now
Yes, sir.
what is this distribution of my normal distribution or without normal distribution if I'm going to represent this data? See, this is my distribution. So one is the maximum chance. So basically it is saying my trial has out of, if I'm going to put 10 trials, maximum like 2 times I might basically get a positive outcome for this particular card example, right? So card example, I'll be getting this if I'm taking a coin toss, so which will be 0.5. So let me see what is, see for a coin toss, it is showing me higher probability, which is like I have higher chances every like at least third, fourth, fifth, sixth, and seventh and eighth. So I'm getting like higher chances are there. How many bars? 1, 2, 3, 4. At least 6 out of 10 times I'm sorry, 4 out of 10 times I'm able to get a positive outcome is what my coin toss is saying. So if I'm saying it is going to be 100, this will be representing in form of bars. So as the number of trials increases, there is more chances also. So for example, trial number 6, it is maybe it is saying 25 times here likewise. So the chances are higher as my number of trials also increases more.
That Sanchez showing a HT tails.
Sorry?
Oh, sorry, for last workout we do that size
Yeah.
100, p is equal to 0.5. It's twice cost, but
Hmm.
it's not showing a tail or head what the showing, sir.
No, it will not show you tail or head. Where did I mention tail or head? So I mentioned it as probability only, right? So where is
Yeah,
tail or head mentioned?
it's sir. I asking that we mentioned the probability, but how many times showing the head, how many showing the tails? How do we calculate, sir?
See, you know the probability of getting head, right? What is the probability of getting head? 0.5, correct?
Yeah.
So here basically what this says is for every outcome which is greater than 0 or more than 5, at least you can say like, okay, this means that this is something like a head, what you are assuming. So it depends on what you are going to ask, right? If you are asking for a head, you assume 0.5 as a probability and say like, okay, this is going to reoccur these many times. So whatever is positive here is assumed to be as head, or whatever is positive here can be assumed as tail also. It depends on what you are asking for, right? So mostly like if you are asking a head, it has equal probability. That's what I meant here.
Yeah.
See,
Okay, sir.
head and tail has same probability only. So it will not be differentiating amount, right? So if your probability is very low, like what you are saying, the cards example and this, in that case, you see the 1 is basically a positive outcome, 0 is a negative outcome, right? The same thing comes for this as well, but the only thing is when we are representing it in form of a plot or something like this, it will be slightly different. That's what I meant. Okay, so now let's quickly see the difference between a normal distribution and a binomial distribution. Okay, so the main difference between a normal distribution and a binomial distribution is a normal distribution is going to be continuous. Continuous in the sense what? It is going to be like continuous values like 0.1, 0.2, 0.3, 0.4, like that it is going to be. However, binomial distribution is going to be discrete. So what is discrete and continuous? So this is a very important concept. What is discrete versus continuous? So what do you understand by discrete, Raghav, Sashi?
Which is continuous means which is from 0 to it will increase high continuously. There is no gap between.
Mm-hmm. Okay.
Uh, discrete means there have the up and downs between. There
Okay.
is a
No,
gap
I'll tell you.
between the value.
Okay. No, I'll tell you example. See, discrete data is nothing but mostly like a countable values. So, for example, I can say height of a person or shoe size of people, right? It will be 6, 7, 8, 9, 10, 11, depending on the size of your leg. The shoe size will be there. So, this is basically a countable value.
Yes.
But however, continuous values will be something like which will be see continuous values will be height or weight. I'm sorry, discrete is not height. Discrete is only like shoe size or what values we can count or your satisfaction scores between 0 to 5. These things will be discrete values because these are more of like a hand countable. But when uncountable data is there, something which is more of continuous, right? So I'm going to see a height or weight. So height can be like 170.05, 170.15, 170.17, 171.2. Likewise, it will vary, right? So where decimal places will be coming, that data is continuous in nature. Okay. So this is also one of the main difference between our normal distribution and binomial distribution. The normal distribution is continuous. However, binomial distribution is discrete. So why I told discrete? You see the number of times I'm tossing a coin, right? I know whether I'll be tossing it 10 times, 20 times, 100 times, or like there will be a countable value for that. However, the same thing may not be true for a normal distribution. So it can be more of a uncountable value also. So that's why there is a difference between this normal distribution and a binomial distribution. So how do you make it as a normal distribution? You just add kind equal to KDE to this. Then it mostly becomes as a normal distribution. But I think here kind will not work. I think KDE should work. KDE plot, KDE. Something was there, right, previously, I think. Okay, let me show it to you in the next step only. Here, may not show. So I'll show it to you here by showing you a distribution of both normal distribution versus binomial distribution. Okay, so since we already have imported matplotlib, seaborn and all, seaborn alone I will import. So import seaborn as SNS. Okay, I'll import the seaborn module. So now I'm going to create a data. So what kind of data I'm going to create? I'm going to create a dictionary object here. So one object I'm going to name it as normal, which will basically give me the value of a normal distribution. So how can I create a normal distribution, Sashi, Raghav? What function I need to invoke for normal distribution? How I can create a normal distribution, guys? Yeah, random dot normal, right? So for a normal distribution, what are the parameters that are required? I spoke about 3 parameters. That is also given in the help. LOC, scale, and size. Right? So what does LOC mean, Raghav, in a normal distribution? So LOC is nothing but mean. Mean value is considered as LOC. So what are you going to give? So I'm going to first give the value for my LOC, which will be my mean. So I'm going to give the mean as 50. Okay. And the second value that I'll be giving is a scale. So what is the scale? Sashi, what is the scale? Scale will be my standard deviation. Guys, please do revise the concepts, whatever we are studying in the previous class, right? So take out some time. I want both of you to spend some time in knowing what did we learn at least. Just go through it at a high level, right? So I think now the recording is also there with Raghav. So will be useful. So please go through the recordings again and again, or try to revisit these concepts. Okay, because once we go to more advanced topics, these things may not be. It might not be easy for you to recollect later on if you are not going to revise this now. So I'm going to give a mention a size here. So which is basically 1000 or something, 1000 numbers, right? Why I'm doing this? Basically, I'm going to do this to find out a difference between a normal distribution and a binomial distribution, right? So I think this has also put a Poisson, but I didn't take Poisson yet. So I'll remove Poisson for you. Okay, so I'm going to find the difference between the normal distribution and binomial. For binomial also, I'm going to use random.binomial. And it will be having 3 parameters. N will be the number of trials, P will be the probability, and the size represents the values, basically what we are having. Right? You are with me? Raghav, Sashi?
Yes, sir.
See, do spend some time revising these concepts, Raghav. So I understand, like you asked me for finishing the topic faster, right? Yesterday. See, I can go on finishing the topic, that doesn't matter. But if you are not able to replicate this concepts in your interview, or tomorrow when you are going to apply this, then there is no use of doing itself, Raghav,
Yeah, okay, sir.
right? So there is no point in rushing if you are not willing to spend time to learn what we have studied in the class, right?
Yeah, that time asking written notes, I prefer this, sir.
Yeah, no, every time because I know you are even very much interested in this, but definitely I wanted you to spend some time on this topics also. Okay, so we are going to use a distribution plot using SNS. So there is something called displot within SNS where we will be using this. So here I'll be saying the data is going to be this, and what distribution I want. I wanted a normal distribution for this particular value. So I'll be basically giving kind in brackets KDE. What is this KDE, Sashi?
Kernel.
What is kernel density equation? Yeah, you're right. Kernel density equation. So basically this will help us to generate a normal curve across. Okay. So now we'll see a difference between both of these curves. You see there? So the blue one is a normal distribution. The orange one is a binomial distribution. So I have told a curve here to be generated. As you can see, right, a normal distribution is more of like a continuous values it will represent mostly. However, binomial distribution is mostly with a discrete number of values. So what I have told, I have taken the size as the mean is 50. So here I don't have any mean or something, but still it is trying to see. So why I'm trying to put this across is you can see the exact difference visually, the difference between a normal distribution and a binomial distribution. It is very similar, but as you can see, the normal distribution more is trying to look out for continuous values and trying to fit my curve there to this mean. So, and then slowly it is coming down. However, binomial distribution is just going up and then coming down as it is, right? So I wanted you guys to research in next class also along with these assignments about normal distribution, about binomial distribution, where it is useful, how it is used. I want you to do some research on this, Raghav and Sashi.
Yeah, okay, sir.
Right. So from now onwards, what happens is slightly we'll be going to more complex things. And I wanted you guys to spend some more time understanding these concepts, trying to do some research from your end, and then come with more questions to me in the next class. Right, Raghav, Sashi?
Yes, sir.
So both these distributions can be used, but not in all scenarios you can use binomial distribution. Binomial distribution is useful whenever you wanted to know or find out in how many number of specific events you wanted to compute certain values, or trying to see from a toss how many times you will be getting. In those kind of scenarios, binomial will be helpful. But mostly in rest of all the scenarios, normal distribution will be really helpful for you.